Hi, this is Sean Collins, and welcome back to Tutorial 3. Again, I have to split up Tutorial 3 because of the amount of content here. This is going to be Tutorial 3B. I'm hoping that this will be it for Tutorial 3. I have my timer going, and I'm going to move right along. To watch this, you really should have already watched 3A, which is just Tutorial 3. So, covered is some of the variables that we'd be interested in thinking about the normal cardiopulmonary response to activity for. We've sort of identified where in the algorithm we're focusing during this tutorial, with a bit of a highlight of this question of whether or not endurance limited due to disease-specific impairments is present or not. And the major point here is that unexpected findings get attention, and that signs of normal compensation is what is expected. So we're now covering what normal compensation, what normal response to activity would be in the cardiopulmonary system. I then took some time to explain the difference between graded and steady-state work. I then discussed the responses of a variety of these variables during graded work. And as you can see here, most of them increase linearly or near linearly with workload. There are some variables that do not increase linearly with workload, one of which we emphasized was diastolic blood pressure. Another one that I suppose I should mention at this point that does not increase linearly with workload is SpO2. SpO2 does not increase during workload. SpO2 should stay the same, and this means it doesn't increase or decrease. I then mentioned that it is important to discuss some of the relationships between these key variables, and some of these variables we measure and others we infer about. So we often infer about ventilation from respiratory rate, and we can observe in a general sense how deep someone is breathing. We infer cardiac output and total peripheral resistance from blood pressure changes, and then I talked quite a bit about the difference between systolic and diastolic blood pressure as being related to primarily cardiac output and primarily peripheral resistance. We also use heart rate to infer about cardiac output. And up here, this is a relationship that we will talk more about later when we talk about reversibility, and that in patients with heart failure we tend to see that cardiac output will not actually increase in that patient to any significant degree, whereas their VO2 can increase, and it is through changes in the arterial to venous oxygen difference that we see the changes occurring. So now I just want to talk about steady-state activity. So with steady-state activity, we have time, but we cannot say that time and workload are related, because for a significant portion of time, workload will stay the same. That's what it is. So I'm going to put in black, I'm going to put the workload. I'm going to say that workload started at basal levels, which we'll just say that is the line, that is the axis itself, is basal levels, and someone they stand up, and then they start to walk, and they continue to walk at the same pace. That is, the black here is the workload. So what do we expect to happen for many of the variables that changed linearly with workload is that they will go up and then they will reach a steady state. So we could say that about heart rate, VO2, cardiac output, systolic blood pressure, and during this time, variables that tend to not change continue to not change. So we continue to have our diastolic blood pressure, our SpO2. Now, I should add here also respiratory rate, ventilation, tidal volume. These all will, stroke volume, these will rise, they will taper off, and they will maintain steady state. Now, obviously, we are not talking about infinite time. People can usually reach a sustainable steady state workload and maintain that with little change in the variables for close to an hour if we have are properly hydrated and have proper nutrients prior to the hour. If we continue to go beyond that, then further hydration, further nutrients, and sort of environmental conditions become important. But that's not the aim of this discussion. This discussion is primarily talking about these steady state responses of typical cardiopulmonary variables during constant workload. Now, most activities of daily living could be said to be a constant workload activity. It's important to mention that for a lot of the activities you would be monitoring these responses for, they get to a certain level and they stay there. So, be it the workload associated with walking, be it the workload associated with stair climbing, be it the workload associated with standing, be it the workload associated with standing and doing activities with the upper extremities. These are workloads that people try to maintain in order to complete a task, and when they have an endurance impairment, they can't sustain that workload. Now, when someone can't attain a workload, that is slightly different than not being able to sustain a workload. And the variable response would depict that. So if somebody can't sustain a workload, then they would achieve the workload, but their heart rate would continue to elevate. Their systolic blood pressure would continue to elevate. These are under normal circumstances. Their respiratory rate would continue to elevate. So they might be doing this workload here, but their heart rate and they continue to elevate, and then they have to stop the workload and their heart rate would come down. So we see that they have an increase followed by a decrease, but the decrease is associated with stopping the activity. They weren't actually able to achieve a regular steady state in those variables. That's being able to attain but not sustain. If somebody can't walk upstairs at all, then it's not even a discussion about whether or not they can sustain walking up the stairs. And that becomes important in intervention planning. Probably more of a discussion for face-to-face, given case discussions that we'll have in our face-to-face session. That is my timer telling me that we have now done our allotted time. So at this point, I'm going to stop session 3B, and we're going to come back at session 4 and talk about how these variables change if somebody has heart failure and they have a non-normal response.